GFCIs are designed to protect against ground faults by monitoring imbalances between the line side or hot side and the grounded conductor side or neutral side. So when a ground fault occurs, there's going to be an imbalance of the current that's going in as opposed to the current that's leaving. So some of that current is going to be going to the ground fault. The circuitry within the GFCI is going to pick that up, and so it's going to open or trip the GFCI, so there's no longer any power on the device. This rapid operation of the GFCI is what helps to prevent severe shocks or electrocution. NEC 210.8 is all about ground fault circuit interrupter protection for personnel, and this is where the code talks about Class A protection. So GFCI devices, according to 210.8, have to be Class A listed devices. In order to be listed as a Class A GFCI device, the device has to trip within 4 to 6 milliamps when a ground fault is detected. Additionally, a Class A GFCI device will trip within 1/40th of a second if it detects a 6 milliamp or greater leakage. The concept for GFCI protection first was developed in the 1960s by a UC Berkeley professor named Charles Dalziel. What Charles Dalziel came up with was what he called the let-go threshold. Severe shocks or electrocutions can occur because when the current goes through the body, there's an involuntary muscle reaction that causes you to hold on to whatever is causing that shock. Dalziel wanted to determine what was the minimum threshold so someone could actually let go of that wire or let go of that shock hazard so that that would prevent these electrocutions or prevent severe shocks. What he determined was for men, the let go threshold was 60 milliamps. For women, it was 10.5 milliamps, and this is what led to the 4 to 6 milliamp threshold that the Class A GFCI has to meet. Additionally, a UL standard was developed. UL 943 specifies the standards for GFCIs, including things like testing and documentation that have to be included in the packaging. In addition to the manual test button that's required by UL 943, they revised the standard in 2015. They also required a self-test by the unit itself, by the devices, by the breakers themselves. They now have to have a self-test feature. These GFCI devices have internal circuitry that are constantly doing internal tests to make sure that they're functioning for a ground fault condition. Some of them are doing it as much as every 15 minutes. If during the self-test, the GFCI device identifies that it can no longer function properly, it's going to do one of three things. It's going to open the circuit. There's going to be some type of an audible alarm or some type of visual alarm, or it's going to trip the device and prevent it from being reset. So the reset button or the test button is no longer going to be operable. So all of these GFCI devices are designed to fail without power, to fail so they're no longer operating.